Hi students, welcome back. Coming to the next topic in the subject computer organization and architecture is integer representations. So in the integer representations, the integer may be a signed and unsigned integer. So let us see what is this integer representation. Actually, the integer representation is divided into signed numbers and unsigned numbers. So this is unsigned integer, or it may be a signed integer. Okay, so again the signed integer is of three types. The signed integer can be represented in the form of sign and magnitude. Sign and magnitude, and sign can be represented by using 1's complement, or the sign numbers can be represented by using 2's complement. So these are the different types of representations, the integer representation. So the integer is nothing but the numbers. So those numbers can be represented in the form of unsigned and the signed. So the signed again can be represented by using sign and magnitude, 1's complement and 2's complement. So in any representation, whether it is a signed or unsigned, the desirable properties that you have to follow are only 1-bit pattern per value. So whatever the value you have taken, you have to follow only 1-bit pattern, and equal number of positive and negative values should be there. So whatever the number you have taken, so for that number, equal number of positive and negative values should be there, and it should be maximum range of values. So within that range only you have to represent, otherwise it will be overflow. Maximum range of values. And one more thing you have to remember while you are representing the integers, no gaps in the range. No gaps are allowed in the range of the values. So these are the properties that you have to follow whether you are representing a signed number or unsigned number. Now let us see the first integer representation, that is the unsigned representation. So what is an unsigned representation? Unsigned integer. So this unsigned integer is an integer without a sign. It is an integer without a sign value. Without a sign. So this is an unsigned integer. So and also its range is between 0 and positive infinity. So always the unsigned integer should be present in between the 0 and positive integer. So let us see what is the range, number of bits and the range of unsigned integer. So here suppose total number of bits are 8. If 8 bits are there, these 8 bits should follow the range between 0 to 255. So the range means these 8 bits can be represented in 0 to 255 range. So this is a 1-bit pattern, either 0, 1, 2, 0, 1, 1, 0, 0, like the binary numbers. So those binary numbers should be is the range between the 0 to 255. Whereas if you're taking the 16-bit, that range is from 0 to 65535. So like that you can increase 8, 16, 32, 64, 124, like that. You can increase the number of bits, the range is also increased. But one thing you have to follow, remember that the range is always in between the 0 and positive numbers. It should not be negative. So it should be in between the 0 and up to whatever the number it is there, means up to positive integers. So that you have to be followed for unsigned integers. Let us see example. Let us take first example. I'll take 2 examples for each integer representation. Store 7 in an 8-bit memory location. I want to store 7 in an 8-bit memory location. So what I have to do? Solution for this is, the first step you have to follow is, here this is a decimal number. That decimal number first you have to convert into binary number. So first change the number to binary. So the binary representation of 7 is 1 1 1. Okay. So next, you have to add 5 zeros to make total number of 8. So to make it as an 8-bit, you have to add 5 zeros. Add 5 zeros to make total of n of 8 bits. That is, you have to add 5 zeros. 1, 2, 3, 4, 5 and the 7. So total you get how many bits? 1, 2, 3, 4, 5, 6, 7, 8. So the size of this bits is 8 bits. So to make it as an 8-bit number, you have to add 5 zeros to this number. Then you will get 8-bit representation. Now you store these 8 bits in memory location with the help of the registers. Okay. So this is how you have to store the value 7 in an 8-bit memory location. I think you know that the decimal number of the 7 is converted into binary like 1 1. So it will come like, so binary means 2. So 2 3s are 6 and 1 will be the remainder. 2 1s are 1 and 1 will be the remainder. So like this you have to follow. 1 1 1. So this is a binary representation for this decimal number 7. So you have to make it as an LCM. You have to calculate like an LCM and convert the decimal number into binary numbers. So here 1 is 1 1 1 3 ones is a representation of binary number of 7. Let us take one more example. Example 2. So here I want to store. Now I am taking a 16-bit number. So previous I had explained it 7-bit number. Now let me take 16-bit number. Store 258 in a 16-bit memory location. Now I want to store. So these are all the unsigned integer, not a signed. This is unsigned integer. Store 255 in a 16-bit memory location. Okay. So how can I store this 255 decimal number? I have to convert this decimal number to binary number and I have to make that number to 16-bit size and I have to store that value in memory location. That is the procedure. So first you change that number to binary. First change number 258 to binary. So what is the binary value of 258? Let's calculate. 258 to LCM. 2 1s are 2, 2 2s are 4, you will get 1 here, and 2 9s are 18. Okay, so 0 is the remainder. So 2 6s are 12, 2 4s are 8 and 1 will be the remainder. 2 3s are 2s are 4 and 0 is the remainder. 2, it's a 16, 0 is the remainder. 2 8 0 2 4 0 2 2 0 2 1 0. So this is how you have to calculate. So this is a decimal number. Then what will be the binary number here? So I had to go like this. 1, 1, 2, 3, 4, 5, 6 zeros. So 1, 6 zeros, 1 0. So you have, from here you have to calculate 1 0 0 0, like this you have to go up. So this is a binary number, but this is total how many numbers here? 1 2 3 4 5 6 7 8 9. Total only 9 numbers are there, 9 bits are there, but we want 16-bit memory location. So to make this number as a 16-bit memory location, means 16-bit size, you have to add zeros. So to make it as a 16-bit, you have to add 7 zeros. 7 zeros to make total number 16 bits. So add 7 zeros. 1, 2, 3, 4, 5, 6, 7 and 1. 1, 2, 3, 1, 2, 3, 1, 0. So this is the decimal number of 258. That 258 will store in 16-bit memory location. So this result will store in memory location whose size is 16-bit. Okay, so here let us see the example of storing unsigned and signed integers in two different memory locations. So here I had taken 8-bit memory location and 16-bit memory location. So whatever the decimals we have taken, that decimals first if you want to store in 8-bit location, convert into 8-bit. If you want to convert in 16-bit location, you convert into 16-bit, like this procedure. So whatever the procedure I have explained here, you have to follow that procedure and you have to convert. So if you take the 7, the 8-bit location, so 7 decimal number is binary number is 111. To make it as 8-bit, to store this number in 8-bit memory location, you have to add 5 zeros. Okay, so for 16 you have to add 13 zeros. So 234, and this is the binary number for 234, and this is a 16-bit binary number of the 234 to store in 16-bit allocation. So 258, why it is overflow? Because the range is in between 257 to 0 to 257 only. Okay, so if that range of the integer 8-bit allocation is exceed, so you have to be stored in, so I already explained that. Okay, let me see here. So the 8-bit range is from 0 to 255 only, means in between these only you have to save that values. But here the range exceeds to 258, here only 255. So 258, because that's why it is overflow. 8-bit location is overflow, but 16-bit is, it is okay. And for this is also overflow, and this is 16-bit. And coming to here, this is 8-bit allocation is overflow. Why it is 16-bit is also overflow? Then what is the range of 16-bit here? 65535. But here it goes to 1 lakh. Okay, so it exceeds, it is more than that 65,535. So that's why it is, make it as overflow. So this is about the unsigned integers. Thank you.